Dmitry Mendeleev, with a new PhD, was fortunate to be able to attend the conference.
Well, the story is that he was invited to the Karlsruhe conference out of sheer luck. He wasn't famous at that time, so he wouldn't have been someone that they would specifically have invited. He was in the right place at the right time. He was the equivalent of a postdoctoral fellow in Heidelberg at the time of the Karlsruhe conference. The major thing that came out of the Karlsruhe conference was a clearer realization of the distinction between atom and molecule, and this question of that simple gases like hydrogen and nitrogen and oxygen come in the form of diatomic molecules. And the person who brought that out was a Sicilian chemist, Cannizzaro, drawing on the work actually of Avogadro, an Italian chemist who had written about this but had been largely ignored, partly because he was a physicist and chemists didn't read the physics journals, and so on.
Another important result of the Karlsruhe conference was to standardize atomic weights, based on a more accurate set proposed by Cannizzaro. This was an essential step before the periodic system could be fully developed, and within 10 years of the conference, at least 6 different researchers came up with independent versions of the periodic table. Even before the Karlsruhe conference, attempts were made to systemize the elements. One of the earliest partial tables was produced by Leopold Gmelin in 1843, who tried to organize the known chemical triads into a system that made sense. He never realized the idea of periodicity, that the properties of the elements repeat periodically. The first person to do that was Alexandre Émile de Champcatois in 1862.
He was a French geologist, de Champcatois, who had not been at the Karlsruhe conference, but had access to sets of atomic weights. And he actually devised a 3-dimensional periodic system. He had a helical system, so he had a helical line which was arranged rising around a cylinder. And if you looked vertically, you would see elements that were chemically similar. So this is really the first discovery of chemical periodicity. What is chemical periodicity? It's simply the idea that after you move along the elements, there comes a certain point when an element approximately repeats. We have periodicity, just like we have in the days of the week, or the months, or the hours in a day. Things recur. In the case of the periodic table, it is as if an element recurs. De Champcatois is the first person to have discovered this. I think it may be true to say that this is the key discovery, although de Champcatois didn't get much credit for this, because he was a geologist. Chemists don't tend to read the geology journals.
Unfortunately, the diagram that de Champcatois prepared for publication showing his telluric screw was not included in that original article. Perhaps his publisher lost it. Periodic tables are all about diagrams and illustrations, so the article was also unlucky because it lacked the diagram, and his ideas were therefore harder to visualize.
The next person is probably Newlands, John Newlands. He was an industrial chemist, a sugar chemist, never held an academic position. He was using Cannizzaro's atomic weights, and he came up with what he called the law of octaves. And as the story goes, he presented his ideas to the Chemical Society in London, and they basically laughed at him. And they laughed at him partly because he was making an analogy with music in the sense of octaves. Newlands spent the next few years complaining about the fact that his work had been ignored, and he was eventually given the Davy Award, so he gets some credit. And there's no doubt that he reached a quite useful and successful early periodic system, about 5 years before Mendeleev did. There was a very eccentric Danish polymath. He was a chemist, but he was also a linguist. He was also a geologist. He apparently escaped political persecution in Denmark, came to the United States, worked in Iowa some of the time. He founded the first meteorological station anywhere in the US. And he came up with a rather elegant spiral periodic system. It's hard to know exactly how he arrived at his periodic system, because his writing is very flowery, very flamboyant, and nobody has really studied him closely. So, some people have described him as a crank. I think there's a little more to it. There's 1 or 2 PhD theses waiting to be written there on the work of Heinrichs.
Another early developer of the periodic system was William Odling. He attended the Karlsruhe conference and was a well-respected British chemist. He championed the views of Stanislaw Cannizzaro and Amedeo Avogadro on the equal combining volumes of gases, that most simple gaseous elements are diatomic, and that atomic weights needed to be standardized. These views led him to use the new weights to create an ordered chart of the elements, in which it is clear that he recognized the periodic law, that elemental properties repeat periodically. He even made a few tentative predictions about missing elements, but didn't pursue these predictions very strongly.
Peter Meyer was a German chemist, a contemporary of Mendeleev's. He too was at the Karlsruhe conference, so he would have learnt the revised atomic weights firsthand. But it's quite clear that he arrived at a successful periodic system somewhat ahead of Mendeleev. There was some confusion over his publication of the paper, so his paper was published slightly later than Mendeleev. He did not make predictions, however. In fact, he claimed himself, he admitted that he lacked the boldness and the courage to make predictions.
With all these precursors to the periodic table, it seems strange to us today that none of them really caught on.
I think in all of these cases, nobody pursued the periodic table to the extent that Mendeleev did. So Mendeleev didn't rest with just publishing his periodic table. He was continually modifying, trying to find new forms. The thing that Mendeleev had going for him that the others didn't seem to have was that Mendeleev had great confidence in there being an underlying law. So if there are small anomalies and you have a belief in a fundamental underlying law, you can ignore those anomalies, you can claim that those anomalies will eventually be corrected. By being more philosophical, he did not worry too much about what seemed to be anomalies at the time.
All of these people had parts of the puzzle, but it was Dmitri Mendeleev who put it all together, and who gets most of the credit for discovering the periodic system and developing the periodic table. In the next episode of The Elements Unearthed, we'll look at his contribution, how his table has continued to develop, and the place it's had in the history of chemistry.